Hello there. Welcome back to Getting Started with C++ Programming. My name is Richard Snyder, and this is Section 7, the final section of the course. In this section, we're going to take a look at defining data structures and classes. We're going to look at arrays, vectors, and maps. And we're going to create a custom class which will bring together all of the concepts we've been going over throughout this course to create a custom class with a calculator example. In this video, define data structures and classes. In this video, we're going to define a data structure, such as a struct, and we're going to define a class and take a look at the differences and discuss them, since we'll be going a little bit into depth about these two particular things throughout this section. What is a struct? Data struct is a group of objects or variables that are put together in one grouping. Each part of the struct is called a member, and they can have different types associated with it. A struct is essentially a place to group like-mind data types into one area for storage and recall. Structs are simple warehouses in software where you can store many different types of data types all in one warehouse. And you can store, you can instantiate and create new, and save and change everything in one location versus having multiple variables all throughout the code that are confusing. Structs are useful for grouping like a theme of some sort of variables. They all kind of have a reason to be together. Best way to elaborate this is, of course, a code example. I like movies, personally. I like funny movies. So we're going to create a struct of a movie. So this is a struct. As you can see, this is how you declare it. It's like a function, so it's outside of the main. You want to declare it before the main is called because we're using it in the main. And remember, with functions, if it's not declared before they're used, the compiler is not going to know what to do. And you can see this struct doesn't necessarily have any type of, it only has the squiggly brackets, not the regular brackets open and close. The squiggly brackets have a semicolon after it to indicate that this is the end of the struct. Inside the struct, you have your data types. For every movie, you have a name, a rating, a release year, and total amount of sales. And these are two strings and two integers. And that's a simple struct. It's a data warehouse for movies. Again, these particular variables are like-minded, or they're the same because they all relate to the overarching theme of the movie. So that's why a struct is useful. This void print movie is all it's supposed to do is print the struct. We're going to go look at that a little bit in a minute. Here's our main. Now, as you can see, we declare two initial movies, two objects, struct type. Now, if we remove the struct, it should be perfectly fine. There's really no reason to have that there because you don't need to define that it is a struct. It's a movie of struct type, which is shown up here in the declaration struct movie. So we have movie, movie A, movie B. Now, I'm declaring these two objects, two structs on the different lines, but if you wanted to, you can always declare them on the same line with a comma. It saves lines of code. It's a little bit more efficient. I'm only doing it in two separate just to show that they are two separate objects. So that's just for my example. So here in movie A, once this is declared, we have space in memory, and the struct has different parts to it: a name, a rating, a release year, and a total sales. Here in this block, right, we are setting those different members to what they're supposed to be. To set one individually for movie type, the period is used. This period means access the members inside of this struct of movie type. When you access them, I want the name, and I want to set that equal to the string called Spaceballs. You do this for the following different types of members in this struct: for rating, release year, and total sales. And this is just for movie A. This is an independent object in memory. It does not affect movie B. And for movie B, we're doing the same thing: movie B dot name dot rating dot release year dot total sales. And we're setting the Rabbit Hood Men in Tights, PG-13, 1993, and a total amount of sales, a large number. And then we're going to be printing these movies. We're passing this to the print movie function, and it's going to print movie A and then print movie B. We're passing each individual struct in, and each one independently will be printed because they're two separate movies or struct. And notice I'm passing by reference. Why? Well, this is a fair bit of information, and there's no reason to pass by value and duplicating memory underneath the hood, because all we're doing in this is accessing the data and looking at it. We're not changing anything, so there's no real reason to pass by value and create duplicates of memory. Just pass by reference and access it and then put it out to the screen, which is exactly what we're doing. We're outputting here each individual item. But notice that when you're passing it in, the variable is called movie. Even though down here, we're passing in movie A and movie B, two independent movie objects of movie type, they're different. And in the function, it doesn't care about differences of name that is coming in. It's of struct movie type. And because of that, you can access movie.name, movie.rating, movie.release here. Oh yeah, and you don't need struct there. There's no reason for that. So you can just access these things because they're going to be doing the same thing for whatever movie is being passed in. So let's run this and take a look. As you can see, our first movie is named Spaceballs. It's a rated PG. It is released in 1987 and a total amount of sales of 38119,483. The movie name Robin Hood Men in Tights, rating PG-13, release year 1993, total amount of sales 357,39755. Two independent structs movies, and they both were printed out independently. And again, a struct is a warehouse or store like mine data types. What's a class? Well, a class expands on the concept of a data structure. It can contain data types or members like a struct, or as we're calling a data struct, but it also contains functions as well. Classes are utilized in a wide variety of ways, from built-in classes such as string, map, vectors, and arrays. We've seen these things, and we'll go a little bit more in depth a little later. Or you can create custom classes that can be created to perform specific functions. Now, there are different components to a class, and there's different usages and ways to create them. And we're going to go a little bit more in depth into classes in video 7.5. I want to just bring up this topic now because I wanted to discuss really what are the differences between a struct and a class. The main thing is you saw a struct. All it does is it stores data types. That's it. It's a warehouse, stores data types, easy to access, easy to create. Class is a little bit more complex. A class brings together everything we've been discussing in this course. A class can store data types. It has its own functions associated with it, where it can pass variables in, parameters in by reference by value. It can do multiple different functions to unify something that needs to get done in the program, and it's all housed into this one object which can be used. So a class is much more complex, but again, we're going to go over this in video 7.5 and review all that.